Oh, hi. I'd like to discuss alloys for just a moment. Alloys are made exclusively of metals. These alloys are a blend of metals. Things that are to the left of the staircase are metals and lose electrons. Alloys have been known for a long, long time. What we do to make alloys is go ahead and take 1, 2, 3, 4 metals, put them in a cauldron, some type of porcelain dish, heat them up so that they melt, stir, and then we let them cool in a form, or we extrude it. We stretch it out, pound it into shape. You might think of like an old metal worker making horseshoes, or some type of like wheel that's round or something. A very common alloy contains iron and chromium. When chromium is added to iron, we make a steel that is often called stainless or surgical. The chromium helps the iron become very, very shiny and less pitted, so that it's not really like rough, but it's rather smooth. Alloys. That's it. Oh, hi. I'd like to spend a moment or two talking about molecules. Molecules are constructed of strictly non-metals. So these things over to the right. Before we start though, let's go ahead and do something, maybe sacrilegious, but we're going to change the periodic table of the elements. Traditionally, hydrogen appears over here in group 1, over with the metals. And while it's true, hydrogen can be made to act like a group 1, a metal under some circumstances, we see predominant behavior from hydrogen to act as though it's in here, group 7 or 17, and it acts like a non-metal. So on a periodic table of the elements, you can go ahead and fill in this little square and put an H there, and remind yourself that hydrogen really does belong above fluorine. So much of the time behaves like a non-metal. Having said that, some very common non-metals that make up molecules are carbon, oxygen, hydrogen, because it's there now, and nitrogen. These molecules are discrete particles made up of non-metals. For example, this is a molecule. It's constructed of carbon, hydrogen, and oxygen. It so happens, and you wouldn't be expected to know this, this has the name of methanol. Methanol. And up until recently, meth didn't have any other meaning than just one carbon in it. And lately, though, meth has a very cultural connotation. And alcohol. And alcohol ends with OL, so we have ourselves an OL ending. We have one carbon, meth, and an alcohol. Let me put one carbon up on the board, attached to what we call an alcohol group. OH is an alcohol group. And this is almost complete, one carbon and OH. It's going to turn out, as we'll see later, that the nonmetals have a preferred bonding scheme. They like to connect in such a fashion. These like to make one bond, or one line to them. These like to have 2, 3, and 4. If you go ahead and include hydrogen here, students often remember honk, like to honk a car, except spelled with a C, H-O-N-C. And the way that it goes is honk, 1 bond, 2 bonds, 3 bonds, 4 bonds. They use that as a memory technique. Having said that, hydrogen has 1 bond, fine. Oxygen has 2 bonds, that's fine. Carbon, how many bonds does it need? It needs 4, but the formula says that's going to work out just fine, because this is saying that there are 3 hydrogens attached to this carbon. And this is the methanol molecule. Molecules contain strictly non-metals. When we officially name molecules, we have to use some prefixes, such in these 2 molecules. These 2 both exist. When we talk about the formula for molecules, we can't play a charge game. We're not doing ionic compound treatment with like, ooh, -4, -2 doesn't work out for us. So what we do is say there can be different combinations of non-metals in our molecules. We have to tell people which one we're talking about. This one over here is often called carbon monoxide. Carbon, and then oxygen becomes oxide. We give it the IDE ending. It's the non-metal at the end. And we're telling people there's 1 oxygen, so we use the prefix mono, carbon monoxide. Do you know what this one would be called? Carbon dioxide. carbon dioxide. And we have some prefixes we commonly use. Let's go ahead and, as Chem 121 students, put on our note card prefixes 1 through 6. Prefix for 1, mono. Prefix for 2, we've used it already over there, di. Prefix for 3, tri. Prefix for 4, there are several out there. Quad means 4. We happen to use tetra. 5, you probably know what 5 is, like the government building, Washington, D.C., 5 sides, penta. And finally, with 6, we have ourselves hexa. If you're interested in knowing more, have a look real quick. 7 happens to be called hepta. 8, as in octane, gasoline, octa. 9 is nona. And 10 is deca, like a decade. I brought in a bottle of methanol. Methanol is very similar to ethanol. There's an M in front, so it's a little different. Methanol has the OH group attached to CH3. So you could think about it as being this molecule up on the board, but take out a CH2 group in the middle. And so methanol is CH3OH. I'll put some in these Frankenstein-looking jugs. We put these together a few years ago. The tape is just for effect, and we have a couple of nails that we shot through the sides of these containers. Right now, I know that the methanol is starting to evaporate. We have some gaseous molecules of methanol inside the container. The nails are shot into the sides of the container here, and they're separate by maybe about, half an inch, maybe about a centimeter. And if I go ahead and bring a spark up to this, the spark will be transferred into the container, and we'll have a spark, and that could detonate the methanol. We'll give this one a try. That was a nice one. Wow. That one worked well. Interesting.